in this next section, what we're really going to deal with is identifying the components within equations that will perform the different types of translations that we just discussed. So we're actually going to be graphing them on Desmos and just kind of seeing what happens. And so on each of these, the original is going to be red, and the transformed one is going to be blue. And basically what's going to happen is we're just going to graph them and see what happens, and then we'll start kind of taking notes. There's a lot of empty space at the bottom of the paper, and we'll start dealing with that. So we're just going to start typing. So here goes. That's not where I'm going to type it. I'm going to type it here. And when I type it in there, I'll call it f of x. F of x equals x squared. So here's our parent function. I'm going to go to a standard viewing window, default zoom right there. And in case you are following along, then you could click up here at the wrench and click projector mode. Just makes it bigger and bolder. So there's my original. And then g of x, capital X apparently, equals negative x squared. Oh, I want to see what happened, and that is red also. I wanted that to be blue, so now it's blue. There we go, done. So the original is red, the transformed function is blue, and I want to know what that negative did. Well, that negative, that's not it. That negative right there, where I'm pointing with the pointer, with the mouse, right there, see? That negative right there turned the red into the blue, and that looks like it shifted, sorry, wrong choice of words. It reflected the function over the x-axis. So this is an x-axis reflection. Okay, so what it really means is this. If I have some function and I throw a negative in front of the entire function, then I have reflected it over the x-axis. Okay? Let's do the same thing. So for this one, we have negative x squared. So let's go ahead and say what's going to happen. I'm ignoring that minus 6. If these two problems were exactly the same, we know we'd have an x-axis reflection, right? So we have an x-axis reflection. And I wonder what that minus 6 does right there where my mouse is. So let's figure it out. We're going to go to Desmos. We're going to click right here, and we're going to type minus 6. And whoa, where'd it go? Ah, it's down there. So it shifted it down 1, 2, 3, 4, 5, 6. Well, how convenient. That was a 6. It was a negative 6, so it went down 6. So not only is there an x-axis reflection, there is a vertical shift of down 6. I'm going to call it negative 6. Okay, so now we're going to graph the original, which is red, and it's already there, actually, same function. And then we're going to graph this one. So that's going to be x plus 2 in parentheses and squared. So here's the original. It's already there. It's intact. It's ready to go. And then we have x plus 2 in parentheses, and we're going to square it. When I square it, when I type squared here, we're going to see something kind of funky happen. Boom. All right, original is red. The transformed is blue. And there's some random dots on here that are intercepts and x and y intercepts and the point of intersection. Anyway, that's irrelevant. The original started here at 0, 0, or has a vertex at 0, 0, I should say. The one that's been transformed shifted horizontally negative 2. All right, so watch the mouse. Basically, it's going to go 1, 2, and it shifted to the left 2. And that sounds a little counterintuitive. So this is a horizontal shift of negative 2. Okay? So if I have some function and I want to shift it left 2, then I better put a plus 2 in there. Well, then if I wanted to shift it to the right 2, then I'd probably put a minus in there. It's going to be the opposite of what you think for a horizontal shift. That's going to be very important. So let's go to the next one, and I think we could go ahead and start writing a few things down. Okay, so we have a 1/2 here. I wonder what that's going to do. We have x minus 3, and it's in the parentheses. So I'm going to go ahead and tell you what it does. That actually is a horizontal shift. Horizontal translation. And it's going to be 3. Now the question is, does it go left 3 or right 3? Well, here goes. If I had plus 2 in parentheses here, but I actually went negative 2, left 2, then if I have negative 3 here, minus 3, then I'm going to go positive 3. Okay, and I'm actually going to just go ahead and type that. So here's the original. The original didn't change, and I'm not quite finished typing the whole thing, but there it is. So when I had a negative 3 in the parentheses, it went 1, 2, 3 to the right. It's, again, a little counterintuitive. So let's finish typing it. See right here, I'm going to type that minus 2, see what that does. So minus 2, whoa, it shifted it down 2. Okay, so now we have a vertical shift of negative 2. All right, let's pause right here and process this. We're not done yet. We still haven't dealt with the 1/2 in the front, but that's okay. But let me talk about this. Here's what's really going on. When I'm inside the parentheses, or in absolute value bars, as we'll see later, or under a radical, which we'll see here, depending on what we consider to be the inside part. When I'm inside, it's the opposite, and that's horizontal. When I'm outside, that's a vertical shift, and I will obey the sign. So outside, negative 2, yeah, negative 2, you go down 2. Inside says x minus 3, you don't go negative 3, you go positive 3, and it's horizontal. One more piece here. Let's put the 1/2 in the front and see what happens. 1/2. Whoa, that actually got wider. So let's take that out for just a second. This is what it looked like before. And then I did that, and it got wider. Okay, so it had a horizontal, you could say it's a horizontal stretch. I'm going to call it a vertical shrink. And here's one reason I say that. If I take this part out and I take this part out, see, it got a little flatter. So the red got squished a little bit. And so you could call it a horizontal stretch. I'm going to call it a vertical shrink. And we're going to come over to here and we're going to say vertical shrink. And it was basically half of what it was. So you can kind of see that too. So like this coordinate right here, that's at 2, 4. Well, I'm not exactly on the right point, but that's at 2, 4. We'll take half of that. It'd be at 2, 2. See? All right. So let's move on to the next one and start deciding what some of these things do. And we'll start doing this without graphing them. This positive 7, this plus 7, is inside the absolute value bars. So that's going to be horizontal. It's a horizontal shift. This minus 2 is a separate term, and it is outside the bars. That's a vertical shift. And that negative right there, oh, that negative, see that negative right there? And that negative right there, what did that negative do? I believe that gave us an x-axis reflection. And technically that would be the first thing we really did before we started shifting things around, right? Flipped it over. Vertical reflection. So let's type that in. Negative absolute value of x plus 7, and then minus 2. And then up here we'll just put absolute value of x. Absolute value is the button above the enter key. Press shift and then that. Okay, so we indeed have had a horizontal shift going from red to blue. So we went 1, 2, 3, 4, 5, 6, 7. And we went 7 to the left. See? We went 1, 2, 3, 4, 5, 6, 7 to the left. Then we went 2 down. So indeed it was the opposite, and that one is, keep the sign, and it was upside down too. So what was pointing downward is now pointing upward. So it was an x-axis reflection. Technically we did that first and then started sliding things around if we're going to go in some sort of order. Okay, let's do this next one, and then we're going to just start kind of making sense of some of these things. Maybe the next two, and then we'll start doing some other things. So we start with absolute value of x. We're going to have, let's see, let's take all this other stuff out. So let's call this a 1/8. Whoa! All of a sudden that is just much, much wider than it was. And in case you want to know what it is, it's actually 1/8 of what it was. So I'm looking right here, and then I landed a grid mark right there at 8,1. Well, that's 8/8 on the original, so it wasn't all the way up to 8, it's up to 1 now. So it shrank by a scale factor of, it got divided by 8. So basically I'm going to call it a vertical shrink. So I multiplied it by 1/8. It's 1/8 of what it was. And that minus 1 right here, I think you can guess what that does. It's going to slide it down 1. So that is a vertical shift of -1. Okay? Let's do one more, and then we'll start writing down some rules that go along with these things. So let's take that 1/8 out of the front here. We'll put an 8 there. Whoa, now it's much skinnier. So this is a vertical stretch, and it's times 8. Technically, I should say this is times 1/8. And I also have x minus 1, and it's inside the bars. So check that out. It's inside the bars. That tells me it's horizontal. Horizontal shift. And it's going to be the opposite of what you would think. So it's no longer going to be -1. It's going to be +1. So it's going to go to the right one. It's backwards, and I'll prove it to you on the graph. There we go. Went to the right. Cool, huh? Yeah. All right. Let's start getting some of our ideas down. Down here at the bottom, I'm going to write some stuff. And not all of them are parabolas, but I'm going to treat it like a parabola. So if I had some sort of function, I'm going to call it x squared. I'm just using that as an example. But then I'm going to start throwing in some other numbers, and I know it's going to look crazy, like the alphabet vomited on my math problem. But I'm going to write that down. And you've actually seen that before. This kind of goes back to some Math 2 stuff. This is vertex form of a parabola, and you can easily identify the vertex, and the A tells you what to do and all this kind of stuff. But I'm going to talk about what all happens here. If you have a number in the front of your x squared, first of all, if a is negative, and I'm just saying if a is less than 0, then you're going to have a x-axis reflection. Basically, it flips it upside down. You could think of it that way. If a is, whoa, that's an x. Now, I'm going to write something down that's wrong, but we'll fix it. So if a is greater than 1, then I have a stretch. See, like a is greater, that's like an a. Now, I know this is absolute value, and the one at the bottom is squared, but it's the same idea. So if a was 8, then it's stretched. But if it's 1/8, then it shrank, right? Okay, so we're going to say that if a is bigger than 1, then it's a vertical stretch. And we're going to say that if a is less than 1, it's a vertical shrink. And a technically is the scale factor in either case, depending on how you word it. Have to be careful with that. Now, I have accidentally lied to you. I'm kidding. It was on purpose. What if I had like -1/2? Well, -1/2. Oh, okay, what if I had -2? Well, -2. What if a was -2? Well, that's less than 1, but it would still be a stretch, but it would be an x-axis reflection. So here's the deal. When I say these things, I'm really going to be ignoring the sign and just pretending like it's positive. So I'm going to put absolute value on that. Don't get tripped up by that. That just basically means, what's the magnitude of the a? Is it a number that's bigger than 1, or is it a number between 0 and 1, basically? And I'm just trying to look at that and say, does it shrink or stretch? Does it stretch or shrink? And then we're going to have h, and that is my horizontal shift. And then I'm going to have k, which is my vertical shift. And you might be thinking, but wait a minute. You told me earlier that I always disobey the sign on the inside. I agree. Yeah, you're right. And that's why it's minus. Okay, so x minus h. So if h was 10, I'd have x minus 10, and I'd be going in the positive direction, but it would say minus 10, right? Okay. So we got that. And there's one other thing we're going to deal with, and it is this idea right here of what I do when I have a negative that's in there with the x. And this is a little more of an obscure idea, because there's more than one way of interpreting this. But let's do the next one. and it's going to be x to the third. And then down here we're going to have negative x, and it is also to the third. And we could interpret this problem more than one way, but I'm going to go ahead and interpret it the way I intended it to be interpreted. I'm going to say that this original's red, the transformed is blue. I'm going to say that the blue is an x-axis a y-axis reflection of the original function. Now, you could also argue that it is an x-axis reflection. I could reflect red over the x and get blue. I can reflect red over the y and get blue. Either one is a valid argument. Nevertheless, for the sake of where this is going and the fact that I'm looking at this problem and I'm going to make patterns here that will apply here, then I'm going to say that this actually is going to give me a horizontal reflection, a reflection over the y-axis. So we're going to go back here and we're going to say that this is a y-axis reflection. Those are a little more obscure. I'm not going to put it in with my little notes down here. But there we go. Okay, on this one, I'm not even going to graph it. I am going to put parentheses here. And we're going to look at that minus 4 that's outside the parentheses. It's a separate term. That's going to be a vertical shift of down 4. This negative right here is the number in the front, and it is going to be, well, it's less than 0, so I have an x-axis reflection. So this is going to be an x-axis reflection. Okay, let's do the next one. The original function is the square root of x. The one below it has x minus 4. That's technically on the inside of whatever's going on. That is a horizontal shift. So horizontal shift. And I'll disobey that sign. It's plus 4. Okay. I see another horizontal shift. It's the opposite of what you're looking at, so it's minus 3, not plus 3. So I'm going to the left 3. And this negative in the front is going to give me an x-axis reflection. Y-axis reflections are kind of rare. Okay, let's graph this one. I just want to prove a point. So here's the original. SQRT pops up square root, and then down here we'll type SQRT and then negative x, and it is indeed a reflection over the y-axis. So another one of these that's a y-axis reflection. There we go.